In order to use the zero product property, we have to factor. So factoring means different things depending on what our quadratic looks like. In this case, we have a quadratic trinomial. I want to set this equal to 0, so I'm going to bring that 7x over, we'll add it to both sides and subtract 18 from both sides. I moved everything to the left so the x squared term could stay positive. Okay, we need two numbers that multiply to negative 18, that's summed to 7. Those two numbers are going to be 9, negative 2. The zero product property says, let each factor equal 0. After all, it equals 0. All right, let's subtract 9 from both sides to solve for x. One of our solutions will be negative 9, and over here, we're going to add 2 to both sides. Our other solution is negative 2. The way we write this is the solution set containing negative 9 and 2. Okay, in our other problem, we actually only have a binomial as opposed to the trinomial we had before. And that means we're going to look at it a little bit differently. We're going to factor out the GCF of 2 first, and we're left with 16x squared minus 81. Now that we have a binomial here, it is a difference of squares. So that 2 is going to stay out front, and this difference of squares here will become 4x plus 9 and 4x minus 9. Now the ZPP tells us we set each factor to 0, but when we take 2 and set it equal to 0, we have really nowhere to go. That's actually a contradiction, so that one doesn't really matter. It's not going to give us a solution. Instead, we're just going to take 4x plus 9 and set it equal to 0, and we're going to take 4x minus 9 and set it equal to 0. Okay, up top, we're going to subtract 9 from both sides. 4x equals negative 9, dividing by 4 will give us negative 9/4 is one solution. Add this one down here. I'm just going to run out of room if I do everything, so I'm going to add 9 to both sides and divide by 4. And our two solutions here are positive and negative 9/4.